All right, guys, welcome to Simplifying Radicals, all right, or square roots. The first thing I want you to do is circle this. There should be no decimals, because a lot of you guys are probably just going to go straight for your little calculator device. Just start plugging stuff away in your calculator, and it's all going to be wrong. First thing I want you to do over here is to write your perfect square. So go 1 squared equals 2 squared equals 3 squared, so on and so forth. Seven squared equals 8 squared equals 9 squared equals and 10 squared. We're going to do this all the way to 15. All right, and then I want you to write what each one of those are equal to. So all of these blue numbers are called perfect squares because you can take a square root of them and get a whole number. So like if 3 squared is 9, then the square root of 9 equals 3. Okay, this is called a perfect square. So like 5, 6, 7, 8, 9, that's called a perfect square. But like if I took a square root of a number, let's pick a number between 16 and 25. Like if I tried to take the square root of 20, that's going to be like 4.5 something. Okay, so 20 is not a perfect square because it does not come out to a perfect whole number. All of these blue numbers, though, are called perfect squares. Perfect squares because we can take the square root of them and get a whole number. So to simplify, again, we should not see any decimals, but this is going to be simplifying it like a fraction. So just like I've got 4, 6, if I divide both of those by 2, equals 2/3 at the same time. Okay, they both represent the same amount or the same number. Okay, both of those are both equal to 0.6 repeating if you put that in your calculator, but one is in a more simplified form. So that's what we're going to be learning to do with these square roots here at the side. So 16 over here, square root of 16. Well, if you put that in your calculator, square root of 16 is just 4. It's a perfect square. So let's go equals 4. Okay. Square root of 81. Probably figure out what that is. Square root of 100. Easy enough, right? You can get a full whole number from all of those. Now, once I go to the square root of 8, now I'm like, man, I don't have 8 over here. All right. So what we're going to do is we're going to break it apart into two things. And one of them is a perfect square. So a product of both of them. So I'm going to make a little tree. It's almost like a factor tree that you guys did back in the day, where one of these numbers has to be one of these blue numbers over here. Okay. So the square root of 8. Well, 8 would go, well, can't multiply 9 times something. But if I look at the number 4. Okay, 4 is a perfect square, and I can multiply 4 times something to get to 8. Okay, so I normally bring the perfect square first. So I can break this apart into the product of 4 times the square root of 2. Okay, it's just like saying, well, 4 times 2 is 8. But now I can physically take the square root of 4. Once you take the square root, the square root sign goes away. Okay, I know the square root of 4 is 2. So square root of 4, that now, square root of 4 is 2, so it would become 2 square root of 2. And then that is fully simplified because I cannot break down that square root in the product of any perfect square. Okay, I know this is totally different, might look a little weird, but 18, I can't take the square root of 18. But there is something that multiplies into it that you are able to take the square root of. Okay, 18. Well, if I look over here, well, 1's not going to do much. 4, I can't really multiply 4 by anything. Oh, but 9. 9 times something is 18. So I can bring square root of 9 times the square root of 2, because 9 times 2 is 18. One of these numbers, when you break them down, has to be a blue one. Has to be one of the blue ones, because those are perfect squares. So now I'm like, well, square root of 9, I can do something with it. I can simplify it. I can change it into something that I know. Square root of 9 is 3. I can't really take the square root of 2, so I just leave it square root of 2. So this here, 2 square root of 2, that's the same as 2 times the square root of 2, just like 2x means 2 times x. So I could write it 3 square root of 2 or 3 times the square root of 2. Either way is fine. All right, 424. All right, I can do 24. Well, let's go back to 18. Some of you guys might be like, well, I could do maybe 6. 18 is also to 6 times 3. But then I'm like, well, can I take the square root of 6? No. Can I take the square root of 3? No. So I can't really separate it that way. One of those has to be a perfect square. All right, so if I look at letter E, I could break this apart into, well, let's see here. 16, can't do 16 times anything. Well, 25 is too big. 9, no. 4. I can multiply 4 times 6. Some of you guys, with your multiplication facts, you may have to use your calculator quite a bit and just start dividing some of these out. Okay, the square root of 4 is 2, and then be left with the square root of 6. Okay. Now I'm going to let you guys try number 50. Okay, the only blue number that multiplies into 50 is 25. 25 times 2. So then this comes out of the square root. Square root of 25 is 5, is a positive 5, and then bring the square root of 2. All right, go ahead and try number or letter G. Okay, I can separate it as 4 times 3. Square root of 4 is 2, so it would be 2 square root of 3. Try letter H. You can separate square root of 27 to 9 and 3. Square root of 9 is 3, so I get 3 square root of 3. All right, now go ahead and try the next 3, I, J, and K. All right, but now, square root of 6, there's nothing I can do. Nothing multiplies. 1 doesn't go in, 4, nothing. So it's just, boom. You circle it. It's already fully simplified. That would be the same as me asking you to simplify 2/3, right? It's already simplified, so I'm already good. All right. 32. I'd have 16 times 2, which would be 4 square root of 2. Square root of 36 is just 6. Okay, some of you guys might have separated that to 4 times square root of 9. All right, but the square root of 4 is 2, and the square root of 9 is 3, which is 6. Okay, now we're getting into some good stuff here. All right, so keep in mind, 6 square root of 16, this is still multiplication because it's right beside each other. Okay, so I can separate this. 6 square root of 16 is just 4. So this would be the same as 6 times 4, which is 24. Okay, this next one, M. 3, now I can break down square root of 75, right? I think I did the same thing from up here. Maybe I did it. Nope, I used 50, not 75. But 75, anything that's like increments of 25, so think dollars, quarters, you can always break it down into 25. times 3. Okay, and then this square root of 25 is 5 square root of 3. But now I still have this guy that I'm multiplying. So just like this came outside, I always say outside times outside, inside with inside. All right, so since the 3 and the 5 are outside of the square root, I can multiply the 3 times the 5 to get 15 square root of 3 for my final answer. Okay, so anything that is outside that doesn't have a square root, you can still multiply those like you normally would. You would also see that you would be able to divide in the same way. So like anything that's on the outside would go with the outside, anything with the inside goes with the inside. All right, so I'm going to have you guys try at least break down the square root of 20. Okay, square root of 20 would be 4 times 5. Square root of 4 is 2. But now I have this guy, this 5 out front. 5 times 2, since these are both now on the outside, because it's almost like if you take the square root of 4, it's now no longer underneath that square root. So I can bring them out. 2 times 5 is 10 square root of 5. So these are like terms. Anything that doesn't have a square root is treated as like terms, but anything that does also can combine as well. All right. So here, 5 I can't really simplify down. Okay, neither with 2, but I can multiply these outside numbers. So 4 times 3, since they're both on the outside, could give me a 12. And then 5 times square root of 2 could give me the square root of 10. And that's it, because I cannot simplify the square root of 10 at all. All right, and then from here, the outside, this would be 21, square root of 10. Letter Q, outside with outside, 2 times 5 is 10. 6 times 2 is 12. But now, sometimes, I'm not going to be too picky with this, but after you multiply it, I can actually simplify the 12 down into a 4 and a 3, which gives me a 2 square root of 3, but I still have this 10 out here. Outside with outside, 20 square root of 3. I know it seems like a lot. Okay, this is just an introduction.